So let's just start with the outlook, right? So we're going to take our data set, 14 observations, and split it based on what kind of outlook, what value the outlook attribute had in each one of those observations. So outlook could have been sunny, and for sunny we have days 1, 2, 8, 9, and 11. On 2 of those, John played, and on 3 of those, John didn't play. It could be overcast, so there we have days 3, 7, 12, and 13, and on all of those days, it seems that John played, right? So we can immediately make a conclusion. John likes to play when it's overcast, so that's an interesting observation. Or it could be raining, right? And if it's raining, we had 5 rainy days in our data set, and on 3 of those John played, and on 2 of those John didn't play. So after splitting the data set based on the outlook, we have 3 subsets of the data. One subset is a pure subset, so we don't need to do anything further with that subset. But the other 2, they have a mix of positives and negatives. John plays on sometimes, and sometimes he doesn't play. So what we do is we keep splitting those data sets. We pick a different attribute and try to split this data set. So for this data set, suppose that we pick humidity as a splitting parameter, right? Humidity could either be high or normal, and if we split the data, we get 3 days when it was humid and 2 days when it was normal, and whenever the humidity was high, John didn't play, and whenever the humidity was normal, John did play. Okay, so this is great because now we have completely pure subsets. We don't need to split these any further. Every subset contains only days where John plays or only days where John doesn't play. And we do the same thing with the right branch of the tree, where it was raining, right? So for raining, suppose we decide to split on the wind. And the wind is either weak or strong, and if it seems that if we split on those values, whenever the wind was weak, John plays. Whenever the wind was strong, and there were 2 days like that, John doesn't play. So at this point, we are done. We have partitioned our entire training set into small subsets based on a small set of rules, and each subset is completely pure. In each subset, John either plays on all the days that fall into the subset or doesn't play on any of the days that fall into the subset. Okay? So what we can do is we can replace the examples with just a label, right? So if something falls down this branch, the John doesn't play. If something falls down this branch, the John does play. If the weather is overcast, John always plays. So that is the result of the decision tree algorithm. That's what a decision tree algorithm would produce. It's basically a tree with labels at the leaf nodes. And the tree doesn't have to be balanced. Some branches can go a lot deeper than others, but at the end you always have a leaf that corresponds to a pure subset. So then we get our new data point, day 15. It was rainy, humid, and not much wind. So to get a prediction for day 15, we just see which branch it falls into, which branch of the tree that we've built. So it was rainy, so we go to the right branch, and then we look at the wind. The wind was weak, so we end up in this branch, and we would predict that yes, John would play on this particular day. Great. Now, for going forward, we should also note that we don't completely throw away the counts, right? We remember how many positives and negatives we ended up with at each node of the tree. So we started at the root with 9 positives and 5 negatives, and we ended up with leaves that have 0 positives, 3 negatives, 2 positives, 0 negatives, 4 positives, 0 negatives, and so on, and so forth. So those numbers are important because sometimes we will want to prune the tree. So what we will want to do is, instead of splitting on instead of splitting on humidity, in this case, we may decide to cut the tree off, right? And we would end up with an impure set And if some item falls into this left branch of the tree, how would you classify it? Would John play? No, right? Because he played on 2 days, he didn't play on 3 days, so he was more likely not to play than he was to play. So that's when we talk about pruning. Those numbers will become important.